Hello students, are we live? Are we audible? Let me know in the chat box. Let me check. Okay, we are live. Hello everybody. Hello. Hello everybody. Welcome back to your favorite channel, VEDANTU JEE English. I am your organic master teacher on this channel. My name is Nandini. Welcome back to another jam-filled session. Today we are going to solve so many questions from your 12th class organic chemistry. There are numerous reagents that will be asked in your JEE, this one attempt, JEE April attempt. So we are going to look at those reagents which are the most repeated, have the most 80% chances of being asked, and we are going to see how to approach the questions. Number first, number second, how to not get intimidated by big reactions, big molecules in your organic chemistry exam, because whenever bacha, remember one more thing, how much bigger the molecule given to you is, the easier the question is going to be. Remember that thing. That is the simplest funda, because bigger molecules are shown just to scare you away. Otherwise, the reaction would be extremely easy, as I teach you how to approach those questions with a calm and composed mind, and organic chemistry will be easy peasy for you guys. Okay, good evening. Hi everybody. Chalo. So many students have been asking me, before that, let us go to the very first question is on your screen. But before we start solving that, I have one very important news to share, that so many students have been requesting to share my Telegram channel. So I've newly created one. If you're interested to join, then you can join. That is my personal Telegram channel with the name Nandini JEE, right? This is my Telegram channel name. You can search that and you can find me, and I have made it an open discussion group where you can send me your questions so that I will send you answers. I just created it right now for you guys. You can join it for you, especially for your April attempt. Whenever you get any doubts, you can just send me a photo of that question and I will help you solve that out. Just till your April attempt, this channel would be working. Chalo. Understood this thing? Now let us look at the very first question on your screen. Who all are ready to solve this question? Sorry. Yes, we are back here. Who all are ready to solve this question? The question is 2-chloro, 2-methyl pentane on reaction with sodium methoxide in methanol yields. Okay, this is the question given to you, and there are A, B, C options, A, B, C, D options given to you. What do you think should be the answer to that? Try to solve these questions. So right now, whatever questions we're going to do, right, because we've started a 12th class chemistry, you cannot solve those questions without a copy and a pen in your hand, without drawing the molecules, without seeing how the arrow is moving. You will not get the answer. So I request you to take out a copy and pen and start solving with me. So the molecule given to you is 2-chloro, 2-methyl pentane. Let us draw the parent molecule. The parent chain is pentane, which means 1, 2, 3, 4, 5. Pentane. At the second position, there is chloro. At the second position, there is once again methyl group, right? This is the molecule given to you, and you're trying to react it with sodium methoxide, which is NaOMe, in the presence of methanol, MEOH. What should be the reaction in such a case? Can you see what is the first thing that you're seeing over here? We are seeing that we have a base given with us, right? This is a heavy base. Can everybody see? This is a very strong nucleophile. This is a heavy base. Simple NaOH is not given to us. What is given to us? NaOMe, a bulky base. Can everybody see? This is a bulky base, right? So whenever a bulky base is given to us, what is the first thing that should click in your mind? Ki, ma'am, with a bulky base, there is always a possibility of an elimination reaction. Isn't it? Elimination reaction will definitely take place. First possibility. But also look at the reactant over here. What kind of reactant is this? Once if I take away this chlorine molecule, what kind of carbocation can be formed? If I just use it as a base, normal base, then bacha, the carbocation formed in such a case is actually a tertiary carbocation. Can everybody see? Which is a very, very stable carbocation. Hence, this reaction will undergo both kind of reactions, which is SN1 as well as elimination reaction. Is this thing clear to everybody? Because I'm seeing with a very strong nucleophile, SN1 reactions happen. With very bulky base, what extra cheese happen? That elimination reactions take place. So both of these reactions will take place simultaneously. Now tell me, what do you think should be the product from here? What should be the answer? What should be the answer? Yes, first answer I've received by ordinary person. He is saying A, Vishnu Reddy is saying B. Okay. But did you understand the concept? The concept that I just told you. The concept is it will show both elimination and SN1 reaction. Elimination, why? Because a bulky base is used. SN1, why? Because if I remove this chlorine, I'm getting a tertiary carbocation, very stable. Definitely will undergo substitution reaction as well. So let us try to solve this once again. Once again, let us try to solve this. This thing everybody understood? Right? Right? So let us look at the answer here. So if what would happen if this chlorine goes away, this chlorine could be replaced by a OCH3 group, isn't it? 1, 2, 3, 4. Here is that, and here OCH3 can take its place. The OCH3 from NaOMe will take its place. This is the answer from the SN1 reaction, right? From the NaOMe, OCH3 will get attached over here. First product. What can be the second product? Let me just show you over here. Let me just look at this reaction over here. Very clearly you can see. Number first, because of the bulky base, what can happen? This chlorine will go away from here and two kinds of products will be obtained. One is the 𝑧𝒑𝒑𝒔 product. The other is the Hofmann product, right? Both of these products will be obtained because this is a E2 elimination. Secondly, through SN1 reaction, what will happen? This chlorine will be replaced by the OMe group and this kind of product will be obtained. Hence, three kinds of products will be obtained, right? So what you have to understand, you have to look at what kind of reagent, what kind of reactant is given to me, and based on that, make your judgment. Is this thing clear to everybody? Is this thing clear to everybody? A, the correct answer is D. All kinds of products are formed. Even this substitution product, this elimination, as well as this elimination, right? This is a 𝑧𝒑𝒑𝒔 elimination. This one is the 𝑧𝒑𝒑𝒔 elimination. This one is the Hofmann elimination. This one is your SN1 product. So the correct answer is D. All of these. All of these. Understood? I'm moving on to the next question now. Next question again on your screen. On your screen, can everybody see that? Again, a compound is given to you and you have to focus on the compound and the reagent. Can you see this molecule over here is an alkene, right? Can everybody see an alkene over there? And you're reacting it with NBS, N-bromosuccinamide. What is the property of N-bromosuccinamide? First reagent, N-bromosuccinamide. Second reagent is H2O, K2CO3, isn't it? What is the property of N-bromosuccinamide? That it adds bromine on the allylic position. Remember this thing? This is an alkene over here. So, on the allylic position, bromine will be added, isn't it? So, what kind of allylic position does this molecule have? I'm again drawing this molecule over here. This kind of molecule is given to you. Here is the alkene, right? NBS adds bromine on the allylic position. So this compound actually has two allylic positions, isn't it? Isn't it? Number one allylic position is this. Number two allylic position is this. right? Now, where would the substitution actually happen? Can you see? This position is actually sterically hindered due to this compound, right? Due to this alkyl chain, this position is sterically hindered, isn't it? This position is sterically hindered. Hence, what will happen? Here, bromine addition will take place. See, okay? Because through NBS, addition happens on the allylic position. Hence, after that, what will happen? Again, I'm drawing this structure here like this. Here was the alkene, and here your bromine will be added. This is the first, after the using of first reagent. The second is H2O in the presence of K2CO3. What is K2CO3? Potassium carbonate, which is a base, right? Which is a base in presence of H2O. So what will happen? This will replace your Br from here, and instead we'll put what? A substitution reaction will happen, and the final product that you will obtain will be OH will be here like this. So this is the final product after hydrolysis. What will happen? The Br will leave, and this will be the final product form. Is this thing clear to everybody? Is this thing clear? Correct answer is not B. Correct answer is A. Correct answer is A. Does anyone have any doubt in this? Right? So please try to learn these things. Please try to learn these basic things. What did I teach you? NBS. Whenever NBS is a very popular reagent, 100% will be asked in your JEE. You add bromine with NBS on the allylic carbon. So which carbon will you select? Which is the least sterically hindered. Here, due to this alkyl, this position is causing steric hindrance. Hence, bromine will attack on the other position, and after hydrolysis, because bromine is a good leaving group, it will be replaced by the OH group. Is this thing clear to everybody? Okay. Okay, and before I move on to the next question, I again want to inform you, notify you that Vedantu is offline, right? Remember this thing, Vedantu, if you want to learn more with Vedantu, if you are someone who is preparing for JEE 2025 especially, then you can join the Vedantu offline learning program, and we are live in your city. In order to check whether Vedantu offline center is Bacha in your city, then please check in the description box below. There is a link. Click on that link and you will be notified whether Vedantu is in your city. And after that, if it happens to be in a city or near your city and you want to join that, then there are certain numbers, certain contact numbers, certain email IDs given where you can make an appointment and go and look at yourself. And Vedantu is live in even Patna, right? If you are from Bihar, Patna, or somewhere around it and you have the accessibility to go. So, our master teachers, all of them, the master teachers you've been watching on YouTube, will be arriving in Patna on March 31st, which is a Sunday. And this is the address. The address is Gyan Bhavan, Gandhi Maidan Road, Muradpur, Patna, right? So you can go and meet your favorite mentors, ask them your questions, grill them, right? Tell us, or you can just ask for advice as well. Beta, I do not teach offline yet, but I will teach offline very, very soon, and I will inform you on which center you can come meet me, right? Chalo, chalo. Now, this, we have already done this question. The correct answer was A, right? So you will get this PDF with the answers on your Telegram channel. Now, the next question is on your screen. Once again, very important reagent. The reagent is the reaction of propene. We are talking about propene with HOCl. Proceeds through the intermediate. What intermediate will be formed when I react? Propene is CH3, CH double bond, CH2, right? And you want to react it with HOCl, right? Now, what would be the intermediate form? Very easy question. Once again, extremely easy question. Okay, I'm giving you 30 seconds to answer this, then I will tell you how to approach this question. What do you see? I see an alkene here, and I see a mixture of Cl2 and H2O, right? Here oxygen will have what? Lone pair of electrons. Remember this thing, right? Here again the alkene has a lone pair of electron. HOCl is actually also a very, very good acid, right? HOCl is a strong acid. So it also gives out H plus ions, right? So try to answer this question. I'm looking at the chat box. I am looking at the chat box. Yes, bacha. Hi, Mishti. Welcome back to the session. Beta, try to solve as many questions as Mishti is saying ki ma'am, my reactions of chemistry are weak. Please help. So, bacha, first of all, do not get scared of these reactions. I know when I was your age, right, these reactions used to scare me. And how did I come out of that fear? After practicing a lot of questions. And I will give you another advice. Another advice is कि right now focus majorly on chemistry. Why? Because chemistry is one portion which you can get 100% right in your JEE exam, right? If right now you put your 100% effort in either physics or maths, what will happen? Those will not garner you as much marks as chemistry can, right? So focus, like if you are putting, if you have divided your focus, right? So put more focus on organic, because again, organic will be like more than 33% of the paper will be just organic chemistry. The organic portion is huge now, right? So 10 to 12 questions, sometimes even 13, 14 questions are from organic chemistry. Try to solve as many questions, and especially all the questions that we're doing here now, bacha, even if you do that much, would be enough for you, right? And after that, if you want more practice sheets, if you want to solve more reactions, if you have questions, please connect with me on Telegram. I am telling you, I'll be available to you most of the time, except the night time when I'll be sleeping. Otherwise, I'll be available for you guys, right? A is the most stable carbocation. Anonymous has answered. Sabitha has answered. Game over Tamil. C, C, C. Okay, okay. So whoever answered A, 𝑠𝑣𝑎, very, very good. You're extremely right. What will happen? This HOCl I just said, it is an acid. It will give out H plus. What will happen? So the next step would be the addition of H plus. So CH3, CH, CH2, right? So here the H will be added and the positive charge will come here so that we can form a secondary carbocation like this. So this is the intermediate form. We are talking about the intermediate, not the final product. So the intermediate is actually A. Okay? So the intermediate is actually A. Is everybody getting this? Is everybody getting this? Okay? CH2Cl. Here it will be again H. Here it will be, bacha, not Cl. It will be CH2 and CH3, right? So this is the intermediate. There is some misprinting in the question, but this is the correct answer. Okay? Chalo, let us move forward. Let us move forward to the next question right now. The next question is this. Among the following compounds 1 to 4, which of the following forms a yellow precipitate on reacting sequentially with NaOH, dilute HNO3 and then dilute AgNO3? What do you think should be the answer to this? Beta, Karthik, I am working on them. They actually take a lot of time, right? Because I need to first search, make slides out of them. I'm doing that. Trust me, today is 28th, tomorrow is Easter 20. Tomorrow is the Easter, right? On 30th, you'll be getting approximately 30 videos uploaded in one day. Okay? So we will be doing our organic chemistry on 30th, more videos will be uploaded. Right now, I'm working on them so that before 4th of April, you can get the maximum organic chemistry to you guys. I am talking about the short videos, a playlist which is created on this channel, right? Yes, bacha. But Cl is attached. Beta, here what will happen? Here what will happen actually, because HOCl is taken. So H plus it will definitely give out, right? So because I think this, if that has to be the question, right? From this you have to select the most extreme correct pair. So sometimes questions like this can exist because this is organic chemistry once again. So you again have to focus on the kind of carbocation form, right? If Cl is attached or not attached, and we know that chlorine only will be attached, OH will not be attached because HOCl is an acid. Try to approach these questions like this. Try to not go into the very detail because sometimes organic chemistry gets a little tricky, right? So here we know that secondary carbocation will be more stable, and because this is an acid only, there is a possibility of the attachment of chlorine over here, right? There cannot be the attachment of OH, right? Because this is not a base that it will give out OH molecule. Okay? Chalo, next. B option, fourth option I'm getting, fourth option. Very good. Whoever has answered B, Sanjay has answered C, Sambita has answered B, ordinary person B, Yash, okay. Ordinary person B is very good. The correct answer is actually B, which means the fourth option, right? So, bacha, what is happening over here? Among the following compounds 1 to 4, which forms a yellow precipitate with AgNO3, right? AgNO3, what will happen? Here, we only look at where all the halogens are attached. Here, the halogen is directly attached to the aromatic ring. Here, once again, chlorine is directly attached to the aromatic ring. Here, bromine directly attached to the aromatic ring. But here, CH2I is not directly attached to the aromatic ring. Okay, first of all, understand this concept. This is the benzene ring, right? And if any halogen atom, I am taking it as X. What it has lone pair of electrons on it, just like this, right? So if any benzene ring is present, and what can this halogen atom do? Halogen is electron rich. Hence, it can donate its electron to the benzene ring to form resonating structures, right? So it can form a resonating structure just like this, and therefore this halogen and arene will get a double bond character like this. Can everybody see that? That this bond has now gotten a double bonded character due to the resonance. Hence, this bond becomes a very strong bond. Is this thing clear to guys? This becomes a strong bond, hence we can never break this bond. This bond is very difficult to break. Only under extreme conditions of pressure, extreme conditions of heat, this bond can be broken. Hence, this is a very easy question. You don't even have to solve it, because here what can happen, this bond is easy to break. So this will definitely break, and the precipitate that you will get with AgNO3 will be AgI, right? All other bonds of halogens cannot be broken. Only this bond can be broken because this iodine is not taking part in resonance with the benzene ring. Correct? Understood this thing, everybody? Why no third? Third is first, but here again, this bond is difficult to break, right? This bond is difficult to break because this bond will get a double bond character due to resonance. Is this thing clear to everybody? Is this thing clear to everybody? Okay, chalo. I'll move on to the next question on your screen. In the following sequence of reaction, the P is again, this is a very important kind of reaction sequences. Try to approach these questions with a calm and composed mind. Very easy reactions, very easy. Most of them would be simple acid-base reactions, right? You don't have to remember much reagents because right now the focus is on the very basic of chemistry. If we see the current trend of JEE, try to answer this. Can everybody see this is a alkyl halide and a Mg is given to you, right? Mg in dry ether, which means what? Grignard reagent will be formed. So the first step A, so the first product A will be a Grignard reagent like this. Here will be the MgCl, isn't it? This kind of Grignard reagent will be the first product A, and then you're trying to react it with ethanol. Which is CH3CH2OH. Okay, and we know with Grignard reagent, even very weak acids give away H plus very easily, right? So the final products formed will be a normal cyclopentane because this thing will be replaced by the hydrogen from here. That is it. That is the entire reaction. The correct answer is actually a simple cyclopentane, because with the Grignard reagent, what happens? Very weak acids as well. Even, not even ethanol, even if you use simple water, right? Or simple methanol, what can happen? They give out hydrogen easily, and hence reduction happens very easily. Understood this thing? Understood this thing? Correct answer is A, bacha, not B. A, there will be no substitution taking place. What is happening? Okay, why will B not be the product? Many people are saying B. Look at the structure over here. Look at the structure over here. I'm changing pen color once again. Once again. Okay, here magnesium has a positive charge. Everybody agrees? Everybody agrees? People are doing substitution here. No. Here, positive charge on magnesium, because magnesium is a metal. Here, therefore, this species, this carbon will definitely get a delta negative charge, right? Because two positives cannot be together. This carbon will get a delta negative because magnesium is a more electropositive metal, so it will get a delta positive charge, right? Now you are trying to react it with methanol, है ना? So here what will happen? The oxygen over here is actually electron rich. Do you think the oxygen over here will go and attack this negative charged carbon? How can it happen? It cannot happen. This reaction will not happen. Instead, what happens? This will easily give out H plus, right? And this positive species will now attack this negative carbon, and the hydrogen will get attached over here. And the another product you will get will be Mg with a Cl product and a OC2H5 product like this. So this is the final product that you will get. Understood? Understood, because oxygen is electron rich. If I'm electron rich, I cannot attack another negative species. I will attack another positive species. है ना? Only positive and negative can attack. So this is a very basic acid-base reaction. Acid-base reaction, right? So please understand these basics of organic chemistry. Understood? Understood? ठीक है? So why OCH3? So why B will not be the product? Because oxygen, being electron rich, cannot attack this position. Understood this thing, everybody? Tell me okay, yes? ठीक है? ठीक है? चलो. Next is, okay, we've done this. This is the answer. Next question on your screen. I'm giving you side. ठीक है? Try to solve this question. Again, don't be intimidated. Very extremely easy question. Just take it as a extremely easy question. You have to identify A and B in the reaction. Again, an alkene is given to you, right? In the presence of HCl, what will be the product A? Then you're trying to react it with NaI diacetone. What kind of reaction is that? NaI diacetone. Name reaction. Who can answer? I'm looking at the chat box. Name reaction from haloalkanes and haloarenes. Who can answer this? NaI and diacetone. What reagent is that? What reagent is that? Who can answer that for me? Yes. Try to solve this question. I'll tell you the answer in one bit. Just tell me the name of this reaction. Where is this reagent used? What name reaction is this? NaI and diacetone. I'm looking at the chat box. Very, very good. Akhil is the first person to give me the answer. Very good, Akhil. Very good, game over Tamil. Very good, art in gallery, Sanjay, Omesh, Varun. It's not Finkelstein, it's Finkelstein. Okay? This is the Finkelstein name reaction. Right. Very good, from the haloalkanes and haloarenes chapter, trying to identify these reagents. See, very important once again. So I'm going to try to solve this question. Again, HCl is given to you. HCl is an acid, which means it will easily give away H plus ions, isn't it? It will easily give away H plus ions. Now, where will the H plus ion attack? Where will the H plus ion attack? Who can tell me? Who can tell me? Hannah, can everybody see there's a alkene? Alkenes are electron rich. So they will definitely attack this H plus. So the next thing would be something like this. Here will be OCH3. Here it is your NO2. Okay? So where will, now the question arises, where will the positive charge come? And where will the hydrogen attach? So can everybody see? NO2 here is a electron withdrawing group, isn't it? This is a electron withdrawing group. OCH3 is actually the electron releasing group. Everybody is familiar with that? This is a electron releasing group, right? Everybody knows that. Okay. Now what can happen? Now where will the positive charge be more stable? Positive charge will be more stable here because here the electron donating groups are attached. Can everybody see? है ना? Electron releasing group is attached, hence it will stabilize this positive charge, isn't it? So this positive charge will be stable more over here than over here because here electron withdrawing groups are attached. So if I'm positive and you're taking out electrons from me, you're making me more unstable. And if I'm positive, giving me electrons, which means you're making me stable, right? So here the positive charge will be stable, hence H will be attached over here. Understood this thing? Now the next species is Cl minus from here. So now the Cl minus will attack and here, okay? So the correct answer for A will be something like this. This. Here is the OCH3. Here will be your Cl. Here will be your H. Here will be your NO2 group. This is the A option, okay? And for the B is a simple halogen exchange reaction, Finkelstein reaction. So what will happen? This chlorine simply will be replaced by iodine, isn't it? This chlorine simply will be replaced by iodine. Hence the correct answer would look something like this. Here is the OCH3 molecule. Here is the I molecule. Here is the H molecule. Here is the NO2 molecule. This is your B product. Is this thing clear to everybody? This is the B product. That was the A product. So now let us look at the options. Let us look at the options. What do you think is the correct answer now? What do you think? B. Very, very good. Very, very good. The correct answer, not B, but cha. The correct answer is C. This one. This is a C option. The correct answer is C. This one and this one. Okay? Everybody understood? Chalo. Let us go. This is C. This is the solution to that question. Now, next question on your screen. Which of the following, again a very, very easy question. Which of the following reagents is not suitable for elimination reaction? What do you have to perform? Elimination, right? So you have a alkyl bromide. Which of these reagents can not be used for elimination? Try to answer this. Looking at the chat box once again. Looking at the chat box once again, giving you just 30 seconds to solve. Again, a very easy question. Very, very easy peasy question. D. First answer received by Maheshwaran D, Abhinav D, Nikhil D, Abhinav D, Cricketer D. Okay, very, very good. Sanjay D. Very good. Correct answer is D, NaI. NaI cannot cause any elimination, while all others are bases. Bases can cause elimination, especially if you are a bulky base, especially if you are a strong base, right? So here this will also cause elimination, this also and this also, right? And why even this will cause elimination? Because the bromine, after leaving the bromine, the carbocation created is a primary carbocation, right? So elimination will definitely happen, okay? Next question correct. Everybody was correct. Give yourself a round of applause. Chalo, next question again on your screen. Which of the following compounds will not undergo Friedel-Crafts reaction with benzene? Okay, I've explained it to you. I have actually, if you want to learn Friedel-Crafts reaction, if you want to learn what are the limitations, what kind of reagents do not show Friedel-Crafts reaction, what are the conditions for Friedel-Crafts alkylation, acylation, do rearrangements happen in Friedel-Crafts reaction, right? And the other thing is, how do within the same molecule, Friedel-Crafts reaction takes place? All these questions have been asked in your JEE exam. I have made already a video on that, uploaded that video. Go check it out in the playlist, right? Try to solve this question. Again, I'm looking at the screen. First answer I've received by Omjit C, Abhinav B, Bhavya B, Sanjay B. Okay. Okay, B. Beta, right now I cannot tell you. For that, here let's solve these questions. SSDA. Okay, I'm getting mixed answers. Most people agree with B. Very good people. Whoever said B is the correct answer. So what is Friedel-Crafts reaction? Once again, recall. In Friedel-Crafts reaction, there is a benzene ring, right? Benzene ring, what is the property of benzene ring? Can you see there are 3 pi bonds in benzene ring? Hence, the benzene ring is actually electron-rich structure, isn't it? It is very electron-rich. And in your Friedel-Crafts alkylation, you actually do reaction with some alkyl chloride, right? In the presence of a Lewis acid like AlCl3. Finally, what will happen? This AlCl4 minus goes away, and what is remained with you is a R plus electrophile. So what is forming in the end? A electrophile, a carbocation is forming after the chlorine moves away. So because now benzene is electron rich, it will attack this carbocation over here, and that's how your alkylating benzene is formed as the final product. So this is the final Friedel-Crafts reaction, right? So now let us look at what kind of carbocations are formed in these cases. So first of all, look at B. If I remove this chlorine from here, what kind of carbocation am I getting? I am actually getting here in the B option, I am getting a vinyl carbocation. What is this called? This is called a vinyl carbocation, which are extremely unstable. What are these? Very unstable species. Hence, these will never be formed. Whatever are unstable, bacha, do not want to be formed. They do not exist only. They do not want to be formed. Hence, this will not give your Friedel-Crafts reaction. Hence, the correct answer is actually B. Similarly, what else will not give Friedel-Crafts reaction? I'm giving you free extra knowledge. That is your aryl halide. For example, if you use a benzene ring, right, as your alkyl, as your RCl molecule, here if this Cl goes away, you will get a phenyl carbocation. This is, once again, this is called phenyl carbocation, which is once again very unstable species. Hence, this will also not be formed. So, what do you understand? In Friedel-Crafts reaction, this RCl cannot be either a vinyl chloride, or can also not be a aryl chloride. Why? Because the carbocations formed are very unstable in these cases. Hence, the correct answer for this is B, because this carbocation can never be formed. Is this thing clear to everybody? Is this thing clear to everybody? Okay? ठीक है? Shiva is asking me difference between staggered and eclipse confirmation. Bacha, right now we're solving questions. If I try to do that, right, most of the students who have joined to just answer, to just solve questions with me, will not like it right now, because this is not a lecture on that. But understand one more thing. I have created a playlist on this channel where so many organic videos will be uploaded, and I will definitely upload even this thing for you, Shiva, which is the difference between staggered and eclipse. On 30th, you can go and see that video. Okay, on 30th, it would be uploaded. Now, let's move on to the next question. The next question is, the major product of the following reaction is, who can answer this question for me? Why not C? Somebody is asking now, why not C? See, bacha, if it goes away, this is becoming such a stable carbocation. This is allylic carbocation, right? This is what it is forming, allylic. Very stable, because it can undergo resonance. This is a very stable carbocation. This will definitely undergo Friedel-Crafts reaction, right? Understood? Shall I move forward? Next question on your screen. The major product of the following reaction. See, we have discussed this kind of question already. I expect an answer from you, giving you 30 seconds to answer. Try to answer this question. 30 seconds. Okay. Try to answer this question. Yes. The major products of the following reaction. D, first answer I've got it is D. Extremely good, Abhinav. Abhinav Dilip Kumar. Wow, proud of you. Shiva D. Okay, very good, Shiva. Okay, Sanjay D. Wow, everybody's right. Pradeep has given me a different answer. B, he has given me Telugu movie. C, Malika. A. Okay, I'm receiving mixed answers now. Now, once again, look at the reagent. Everybody look at the reagent. What kind of reagent is this? NaOMe, which means it is a bulky reagent. Is it a bulky base? It is a bulky base. What is the property of bulky base? That they cause elimination reaction, isn't it? Definitely there will be elimination reaction, right? So what kind of elimination actually will happen? What kind of elimination? What will happen to elimination? What is the property of a base? NaOMe is a base. What is the property? To abstract proton. Always understand this. A base abstracts proton. Abstract H plus. What is the proton? H plus, right? So this is the molecule given to you. I'm once again drawing the molecule over here. The molecule is a cyclohexane structure. Here is this, and here the bromine is attached. Okay? This kind of structure. Now, what kind of elimination actually happens? Beta elimination. Beta means, for example, if to this carbon bromine is attached, the carbon next to it will be the beta carbon. So now this has two beta carbon. One beta carbon is this, second beta carbon is this, isn't it? This carbon to which the bromine is attached, two beta carbons are there, right? Now from where the hydrogen will be removed? Can you see, do anybody see any hydrogen present over here? There is not even any hydrogen here. So hydrogens will not be abstracted from here. Instead, the hydrogen will go away from here, right? So after the hydrogen goes away from here, then the bromine will go away. So first of all, hydrogen leaves. After that, the bromine will leave. Understand this thing, okay? Now the next thing would be the formation of the product, which will look like this. So this is the final alkene formed. So the correct answer is D. Understood this thing? So first, because the bulky base is there, I identified MAM elimination. Elimination of what? Dehydrohalogenation. Here elimination happens of minus HBr, right? What will be removed? Minus HBr. Dehydrohalogenation, minus HBr. So first of all, because the base is there, base obviously and always abstract a proton first. So from the beta carbon, I identify where the hydrogen is present. So hydrogen is only present over here. So it will abstract the hydrogen from here. Then the bromine will go, and then an alkene will be formed just like this. Understood this, everybody? Understood this? Okay? Chalo, next. Next question on your screen. The major product obtained from the E2 elimination of 3-bromo-2-fluoropentane. See, we've already done such a question. Okay, I expect you to answer this. See, in every question there will be something new will be there. That's why only I've added this here now, to teach you something new. Every question will not be the exact copy of the other one, but you will learn some other thing out of the similar kind of reactions. So there are so many pointers to know in organic chemistry. I'm telling you, it is not easy until you solve many questions and get used to them, right? Chalo. So the question is, a major product obtained from the elimination of 3-bromo-2-fluoropentane. How do you draw that structure? Pentane. Pentane 1, 2, 3, 4, 5. This is the formula for pentane. Then on the second position there is fluorine. I've attached a fluorine. On the third position there is bromine. I've attached a bromine. This is the reactant given to you. And you want to do E2 elimination. I just told you. E2 elimination means what? Dehydrohalogenation. Dehydrohalogenation, which means that there will be subtraction of one hydrogen and one halogen. So can you see in this compound there are two kinds of halogens now? Which halogen will leave? Who can answer this? Just answer this for me. Then I will tell you how to approach this. Which of these two halogens should leave according to you? Should it be bromine or fluorine? Only one will leave, right? Because only one time we're doing the dehydrohalogenation. Br, very good Maheshwaran, very good. So here what will happen, bacha, Br, bromine is a bigger molecule than fluorine, isn't it? And bigger molecules will form longer bonds. And longer bonds are easier to break, isn't it? So this bond is very, very easy to break. So here I definitely know that bromine will leave. Ma'am, I definitely know that. But which hydrogen will leave now? I told you the elimination is from the beta position. It is a beta elimination, isn't it? Beta elimination, right? So there are two conditions from where the hydrogen can leave. The hydrogen can leave either from this beta position, this is also beta position, and this is also the beta position for this bromine, isn't it? From where the hydrogen will leave now? So, bacha, can you see on this carbon, the fluorine is attached, right? On this, the fluorine is attached. Fluorine shows what kind of effect? Minus I effect, isn't it? So because fluorine is so much electronegative in nature, it pulls the electrons towards itself. Hence the hydrogen which is attached over here, hence the hydrogen which is attached over here becomes very acidic hydrogen. This hydrogen becomes very acidic whenever a hydrogen is near to electron withdrawing groups. That hydrogen is acidic in nature. Remember this thing. Keep it in mind. Make a pointer out of it. Whenever a hydrogen is near the fluorine. So this is more acidic. Now I know. Hence, the more acidic means what? It easily gives out H+. So this will be the first to go, then this Br. So the final products will look something like this. The Br will go from here. This will go from here. Here will be the fluorine. So this is the final product. This is the final product. So now answer, which of these options do you see is correct? Which of these options is correct now? Sanjay, how? Look at the options. Look at the options. D is not the correct answer. A. Yes, Maheshwaran is extremely correct. The correct answer is A. Right? They just have written it in a different format. Don't get confused. See, this is the same alkyl chain. This is the same alkyl chain. Right? This is one alkyl chain. On the second carbon, there is fluorine. Do not get confused. This is a single chain. They just have represented in a different manner just to confuse you, right? The double bond is directly next to the fluorine. This is the correct answer. Understood? Why is that the correct answer? Which hydrogen is acidic? All these make whatever points I'm saying now, what you should be doing. If you are a very serious student, right? If you are not, then obviously you just see this video, relax in your bed and that's it. But if you're a serious student, make pointers out of everything. Okay, if some hydrogen is right next to the electron withdrawing group, then that is the acidic hydrogen. It will leave first. If I have to choose between two hydrogens, right? So make these pointers for your own benefit, correct? Because you're starting out. Very good. Now the next question on the screen. The major product of the following reaction, if it occurs by SN2 mechanism is SN2. Understand? SN2 mechanism, which means what kind of reaction is happening? Substitution. SN2 is which reaction? Where a single step reaction happens and the attacking agent nucleophile comes from the back, isn't it? So here, which will be the nucleophile and which will be the electrophile? Who can answer that for me? Which will act as a nucleophile here? So you again have a base. K2CO3 is a weak base, but it is a base, right? It is a base. So substitution SN2 reaction is happening. How will it happen? Beta, if the hydrogen leaves, then afterwards the bromine will leave. Somebody is asking, ma'am, how the beta hydrogen will leave from here, then afterwards the bromine will leave, and therefore a double bond will be formed here. What is not, what is the thing you're not able to understand? First the hydrogen will leave, then the bromine will leave, and a double bond will be formed. Simple, right? ठीक है? Chalo, next, try to answer this question for me. So what do you see in this? First answer I've gotten by Sanjay. Okay, Shiva has answered B for me. Very good, Shiva. Wow. ठीक है? A mass gaming D. Bhavya has answered me B once again. D, B, and Sanjay's answered A for this. Okay, let us see what actually happens. So everybody is looking at the reactants over here. Okay, bromine has a delta negative charge. Everybody agrees to that? Everybody agrees to that. Bromine has a delta negative charge. Therefore, if the bromine leaves from here, what did I tell you? A substitution reaction will happen. So there will be one leaving group, one attacking group. What will be the attacking group? This oxygen, lone pair of electrons, isn't it? So the nucleophile is this phenol. Understand this. This is the nucleophile from here, isn't it? So what will happen? The bromine will leave from here, and this carbon will get a delta positive charge, right? Now the electrons on the oxygen will attack this delta positive charge over here, and this kind of product will be formed. Very simple product. Very, very simple product, right? Is this thing clear to everybody? A will not be the answer. A will not be the answer. D, B will be the answer. Because here, once again, what will happen? Rearrangement can take place, isn't it? So this is the product. This is double bond. Here is the positive charge coming. Okay? Now what can happen? This double bond can go over here and the positive charge can go over here through resonance, isn't it? So the double bond goes over here, the positive charge comes over here. Now, bacha, this positive charge will now attack on this oxygen and this product will be formed, right? So this is the final product, which is B. Understood this? Understood this, because there is a possibility. Okay, there is SN2 mechanism. Sorry, no rearrangement will happen. Oh my God, what did we do? What did we do? What did we do? Here SN2 is written. 1 second. Yes, okay, don't make the mistake your teacher just did. So here SN2, this is a simple reaction. The bromine will go from here. This is the positive charge created, right? And this will just attack to the backside from here. There will be no positive charge creation. The bromine will leave from here. The OH will attack from the back, right? And the correct answer seems to be the D option, right? SN2 mechanism. Yes, SN2 mechanism, D. No rearrangement. Only bromine will leave from the front and this will attack from the back. One step reaction will happen, correct? So let us not forget to look at the mechanisms over here. Otherwise, yeah, we could have answered this question, right? Chalo, next. Understood transition state? Yes, correct. Next question on your screen. The correct options for the products A and B of the following are. The correct options for the products A and B of the following reactions are, again, a very basic question, very, very basic. Phenol is given to you. Phenol in the presence of Br2 and CS2. What will happen? When Br2 is given in excess, what will happen? Very basic. I expect each one of you to answer this for me. I expect each one of you to answer this for me. Yes. A answer I've gotten very, A could be the answer, but A is not. B, A, B is not the answer. Whoever is answering B is extremely wrong. Nikhil, A is not the answer. A is not the answer. Okay. So look at the A option. A is what? We are reacting phenol with bromine in excess. So what will happen? Bromine will attack because here in the phenol, what is happening? This is the phenol structure, right? This is the phenol structure. The OH is actually a ortho-para-directing group, isn't it? So when bromine is in excess, at all the ortho and the para positions, bromine will be added. So here will be bromine. Here at all the positions, bromine will be added through A when the bromine is in excess. So the A is this option, right? Now when the Br2 is taken in presence of CS2, and less than 5 degrees. This is actually a very good reaction given you, especially in your, I guess, alcohol phenols chapter, right? This reaction, this specific reaction is given to you. This is a specific reaction to create the para product. Otherwise, what happens? You get a normal this product. Okay? So just to get the para product, what do? You react bromine and CS2, and then finally you get just the para product. Otherwise, you're getting a mixture of products from here. So the correct answer is actually B. So whoever answered B is right. Not A, but A will not be the answer. Here at less than 5 degrees you're reacting, which means you have already done the react at less than 5 degrees. What is the meaning of that? The temperature is too low. Hence the reactivity is not that high. If the reactivity is not high, selectivity is high, which means what? At only one position, now the bromine will attack. Because bromine has to attack, so it will attack the best position, which is the least steric hindrance position, which is your para position at such low temperatures. Such low temperatures at the ortho, it will not attack. It is the best way to get a para product, right? Understood this thing? So the correct answer is B. Yes. Okay? Chalo, let us move on to the next question here. Extremely good. Now I want you guys to answer this question with me. Okay? So what do you have? You have some phenol kind of molecule. You are reacting it with concentrated H2SO4 and heating it. So what do you get? After reacting it with acid and heating it, you definitely will get the alkene. Everybody is understanding that? Whenever heat is there, the alkene will definitely be formed. Remember this thing. Okay? Heating means something will leave. Some elimination is going to happen for sure. Consider the above reaction and choose the correct statement. Which of these is the correct statement out of these two? Which of these would be the correct statement? Yes. B. Okay, first answer. B I'm getting by future aspirants. Then B, Abhinav is also given B. Hemuku has given C. Very good. Hemuku is right this time. Ma'am, first you said B is extremely wrong. Now you're changing. Sorry, Sanjay. I thought, you know what? In the last question, I thought this is B. That's why I said this is the correct answer. Okay, sorry. I thought this is B, A, B, C, D. That's why I said sorry, Sanjay. Okay? Your ma'am can also do little pittle mistakes. Chalo. C. Whoever has answered C is extremely right. So what will happen in the very first step? In the very first step, what will happen, bacha? This is your benzene ring. Here is the OH, right? So here H2SO4 will give away H plus ion, isn't it? So what will happen? This OH from here will now attack this H plus, right? And the product that will be formed will look something like this, OH2 plus product, isn't it? Now OH2 will leave from here, and after that you will get a formation of like this, a positive charge, a carbocation. Now the next step is elimination in presence of heat. Okay, in presence of heat, elimination will happen. So bacha, remember this elimination product, this is a trans product and this is a cis product, isn't it? So this one is a cis product where all the reactants, see here the hydrogen will be there, the hydrogen will be there, they're on the same side. So this is a cis product, while this, the hydrogen is here, another hydrogen is here, so this is a trans product, right? So in your elimination reactions, what happened? The trans products are stable. Trans alkenes are more stable than cis alkenes, isn't it? So here the trans alkene will be the major product because it is a stable alkene. Okay? Trans alkene elimination reaction, extremely correct, Sanjay. You are again very right in this question. Okay? Trans alkenes are stable, hence that will be the major product. Next question on your screen. Again you have been given an acid. See, these questions are so prominent, will be asked every time. The question is, consider the above reaction, the major product P formed is. So this is the reaction given to you. Okay? Again, you have an acid. HBr is the acid. It will break down into H plus and Br minus ion, isn't it? Now what will be the reaction? What do you think would be the reaction for this? What do you think would be the reaction for this? Beta, for the Jan session, right, I would advise you to actually take your April attempt very seriously, because the rankings have been very, for some sessions, very low marks also secured you a very good rank. But for the other sessions, even if you're scoring in like, people were scoring 300 plus marks and they were still not getting the 99%. Are you considering that? So I think you should focus on your April attempt, because until and unless you are scoring somewhere above 300, right, in certain papers, then please focus on your April attempt. So, correct answers: A, I'm getting SSD, Sanjay A, Nikhil A, Honey A, Remy Shetty, hi, Honey Shetty Bachcha, Abhinav A, Chandra A, Hemuku is answered D. Okay. Okay, Harish has once again answered A. Ordinary person is answered A. Chalo, let us try to do this question. What do you think where the H plus will attack first of all? We have so many attacking groups over here. We have a alkene over here, right? We have a OH over here. Where do you think the H plus would attack first? Where do you think the H plus would attack first? Answer me. I'm looking at the chat box. Will it attack on the alkene or on the that thing? Or on the that? And we also have COOCH3Br. What do you think will be the attack happening? A. I'm getting so many answers as A. Correct. So what will happen? The oxygen, the OH over here has so many lone pair of electrons, isn't it? So what will happen? Easy peasy, once again, the lone pair of electrons on the oxygen will attack on the H plus, right? And OH2 plus will go away. The positive charge will be created here, and hence the Br will attack over there, right? So the correct answer is definitely your A option, right? What will happen? First of all, this is the question given to you. C double bond OOCH3. Here is the double bond. Here is the OH. So first of all, remember that the lone pairs of electrons will definitely attack the H plus first, and this will form OH2 plus, and this will leaving behind a positive charge over here. Hence, on this positive charge, the Br minus will attack now, and you will get A as the final product, right? Yes, and everybody is right. Whoever said A, extremely correct, extremely correct. Chalo, next question. Main product formed during a reaction of 1-methoxy-naphthalene with hydroiodic acid. First of all, try to draw the structure of 1-methoxy-naphthalene. I will not tell you what it looks like. Okay, I'll give you 30 seconds to try this question. What do you think is the structure of 1-methoxy-naphthalene? Yes. So what is the structure of naphthalene? Naphthalene is a bicyclic molecule like this. This is naphthalene. It looks like this. Sorry. This is a naphthalene molecule, right? At the one position, there is a methoxy group. Here, OMe group is there. So what this is 1-methoxy-naphthalene. Understood this? You are reacting it with HI, hydroiodic acid. Again, very strong acid, right? Easily gives away the H plus ion. Now what will happen? Where will the H plus ion attack now? What should be the answer? Very easy question once again. I am getting already B as the option. Very good. Very good. What will happen? The H plus from here, right? This oxygen's lone pair will attack on this H plus, right? So what will be formed now? Here, like this structure would be formed. This. Here the OH will come, right? And Me will go away. And Me will go away. CH3 will go away as CH3 plus ion, right? Now this I minus will attack this CH3, and the final product you'll get will be CH3I. So these are the final product, which is the B option. Very good. Okay? Whoever answered B is extremely correct. Okay? Extremely correct. Next question on your screen. What is the time, bacha? It's 8 only. Chalo. So we have seen this is the answer. Now next question. Okay. These kind of questions will definitely come. This question or a part of this question will definitely 100% come in your exam. Mark my words. Identify the major products A and B respectively in the following reactions. One other thing we've already done. Br2 in CS2. What would be the reaction to that? Option number A. What will be the product A and the product B? First, before solving this question, let me know what reactant is this? What name reaction is this? Just look at those reactants and tell me which name reaction is that. Which name reaction is that? First answer I'm getting D. Very good. Very extremely good. What name reaction is that? Answer that question for me. D. Very good. Everybody who's answered D is right. C is not the answer. C is not the answer. Answer me my question. Which name reaction? This is not Kolbe. This is not Kolbe. Which name reaction is this? Riemann, first answer by Bineet Chanda. Very good, Bineet. Very, very good. First answer. Then Hemuku has also answered. Anime has also answered. Abhinav answered. Lakshana. Correct answers. Hani has answered. Sanjay has answered. Okay. Ram Prasad, Sumit. Very good. So this is Riemann-Tiemann reaction. This year in January 2024, JEE, this reaction was repeated in 3 papers. Can you imagine how important is this reaction? Riemann-Tiemann reaction, right? Very, very important reaction, Riemann-Tiemann reaction, right? What is happening in this case? You took a phenol. Okay, what will be the product A? The product A, I just told you the bromine will attack. This is the phenol molecule, right? So the product A is what? The bromine will attack at the para position. So this is the product A. What is the product B? It is simple Riemann-Tiemann reaction where what happens? CHO groups get attached at the ortho position. So this is the product B. So the correct answer is definitely your D option. Correct? Correct. Very good. Extremely good. Whoever answered this, very, very good. Next question, again, very easy question. But once again, such questions are very prevalent in your JEE exams. There are 2 statements. Statement number 1, ortho-nitrophenol is steam volatile, which means it has a low boiling point, right? Due to intramolecular hydrogen bonding. Is this statement true or false? Similarly, next statement is ortho-nitrophenol has high melting point due to hydrogen bonding. Once again, is this true or false? Let me know in the chat box. First statement true or false? Second statement true or false? Yes. Answer beta both of them. True, false? Okay. Vemi Shetty has given me first is true, second is false. Very good, Vemi Shetty. Very good. Both are not true, Sumit. Both are not true. Both are Maheshwar and right now are not right. Both are not true. Okay. So first of all, look at statement number 1. Ortho-nitrophenol looks like this. This is how ortho-nitrophenol looks like, right? In ortho-nitrophenol, there is actually intramolecular H bonding. This kind of H bonding is called intramolecular H bonding, right? Remember, within itself, intramolecular H bonds are actually weaker bonds. Weaker than who? Weaker than intermolecular. When between 2 molecules, hydrogen bonding is there, it is stronger. Okay? Weaker than intermolecular. Intermolecular H bond. Remember this thing. Okay? So first statement is true. First statement is definitely true. Second statement, ortho-nitrophenol has high melting point due to hydrogen bonding. No. Melting points do not depend on hydrogen bonding. Melting points only and only depends upon the crystal structure. Remember this point. This is also essential not only for organic chemistry but in your inorganic P block. In P block, you learn about so many melting points, and the melting point order only depends upon the crystal structure. Remember this thing. Melting point depends upon the crystal structure, right? And para-nitrophenols have more symmetric crystals. Hence, they have a higher melting point. Boiling point depends on hydrogen bonding. Melting point depends on crystal structure. Understood? Understood everybody? Yes. So the last statement is false. The first statement is true. ठीक है everybody? Shall we move on to the next question? Chalo. Next question is this. Again, a very basic question. Similar kind of questions are repeated. See, question is, what is the final product? But some changes would be there in order to make you understand basic stuff, because these questions will be repeated every time. What is the final major product A in the given reaction? What do you think would be the major product A in the given reaction? Yes, try to answer this. So the reaction given to you is, you have a alcohol kind of thing. Can you see OH is there? You're reacting with HCl acid, so it will break down as H plus and Cl minus ion, isn't it? It will break down like that, right? ठीक है. A answer I've received by Omesh. Varun has given me the answer as A. Okay. Nikhil has answered D. Beneath D, Sumit D, Abhinav D, Remishati A. Once again, let us see who is right, who is not right. ठीक है. Major product we have to calculate. Now, bacha, what will happen once again? The oxygen's lone pair will attack this H plus over here, right? And this will leaving behind a carbocation over here. ठीक है, a carbocation over here. So what kind of carbocation is this? This is a secondary carbocation, isn't it? The carbocation formed here is secondary. But this secondary carbocation, okay, I'll draw this once again if it is not clearly visible. What will happen? This is the CH3 molecule, right? Here is the CH molecule. Here is the CH3 molecule. So after this OH2 plus leaves, this will leave behind a carbocation here, which is a secondary carbocation, right? But this has the possibility after 1,2 hydride shift. If this hydrogen goes over here, the carbocation then comes over here and can become a tertiary carbocation, which is more stable. So that will definitely happen. Whenever there is a formation of carbocation, remember that rearrangements are definitely going to be possible. There is a possibility rearrangement will happen. Hence, next carbocation will be formed, will be like this. CH3, here will be the positive charge, right? Here will be the CH, here will be the CH3, right? So here the positive charge is formed. Now this Cl minus will attack this positive charge, which is this. So the correct answer is D. Whoever gave the correct answer D is absolutely right. Correct, Sanjay. Before Sanjay, there was somebody else who gave the correct answer. So chlorine will attack this carbocation over here, right? So the correct answer option is D. Yes. Okay, Bhavya, very good, very good. Chalo, next question. Okay, this I want you all to try. I will give you even more than 30 seconds. I will give you 60 seconds now. I think 60 seconds is more time for this, but I want you all to think. Just think. The question is, arrange the following compounds in increasing order of the COH bond length. You have to guess the bond length of carbon and the alcohol group. Carbon-oxygen bond, right? Of methanol, phenol and para-octoxyphenol. I will just draw the structures of that. Methanol is CH3OH, right? This is methanol, right? What is next is phenol. Phenol looks like this. This is the phenol structure. Phenol structure, right? The other structure is para-ethoxyphenol. Para-ethoxyphenol like this. This is again 1, 2, 3 phenol. At the para position there is OC2H5 group. Now tell me the order of bond length will be, what will be the biggest bond length? C answer, C. So many people have already given me the answer. Wow, you don't even need 30 seconds, 60 seconds. Wow, Bhavya, only one person has given me B answer. Okay, he has deleted the answer. D. Suraj Kumar beneath B. Very good, very good. So what is phenol will, according to you, phenol will have the highest bond length? Absolutely, B cannot be the answer. C, methanol. Very good, very good. So whoever has answered C is extremely right. So what will happen? Look at the phenol structure over here. Phenol may oxygen has lone pair of electrons. So these lone pair of electrons will participate in resonance, isn't it? So when they participate in resonance, what will be formed? Resonating structure. And in that resonating structures, this will have a double bond like this, right? So this will have a double bond like this, and a negative charge will go over here, isn't it? So due to, because this is getting a double bonded character, and we know double bonds are smaller bonds, shorter bonds, right? So this will be a shorter bond over here. But what about the case here, ma'am? Here also phenol is there. But can you see, bacha, here there are two competing species. Can you see? Here the methoxy group is also contributing to the resonating structures, right? So now there is a competition between the two, है ना? So here what will happen? This will get lesser contribution in the resonating structures because there's a competition now. So hence this bond length will increase. Okay? And in CH3OH there is no, this is a simple single bond. This is a simple single bond, right? Single bond, and single bonds are longer as there is no resonance. So this will be the longest. Methanol will be the longest, followed by the para-ethoxyphenol, because due to competition from both the sides, this will get lesser chance for contribution. Hence, the bond will be little bit longer if we compare with the phenol, and phenol will have the shortest bond length. Everybody understood this? Everybody understood this? Correct answer is C. ठीक है? ठीक है? चलो. Next question. Now I want everyone to give the correct answer to this very easy question. The increasing order of boiling points of the following is increasing order of boiling point. Boiling point depends upon, I just told you, H bonding. Right now. Now tell me, increasing order of boiling points. Once again, answer me like this. Acting gallery, can you please write in English? I do not understand that language. Sorry, I just know Hindi or English. Please write the question. Ma'am, you are teaching. It's very good. Oh, Sanjay, is it? I do not have the access to the channel actually, Sanjay, so I cannot actually throw them out. Acting gallery, please write to me in English. Okay, first answer I have given received by Hemuku 2431. Sanjay has given me 2134. Aghilan 2341. 321. Oh wow, mixed answers. Right. So I just told you the boiling point will depend upon the hydrogen bonding, right? So where do you think which do you think has the highest hydrogen bonding capacity? Here, can you see the third option over here? The third option has what? It has the OH group and the NH2 group, right? The OH and the NH2 both are very, very strong H bonding candidates. Remember that thing. These are very strong H bonding candidates. Hence, the highest boiling point will be of third. Because you also read about aniline, you also read about phenol, and you've both added in one molecule. Very high boiling point. Oxygen can also form hydrogen bonding. Nitrogens can also form hydrogen bonding, right? Next molecule will be OH and your NO2 molecule, because once again here nitrogen is present. So the next is the molecule number 2, right? Then here OH can form hydrogen bonding. Then your OCH3 over here can once again form hydrogen bonding. Then it is your 4th number. Then it is your 1st number. So whoever answered this is the very right answer. 3rd, 2nd, 4th, 1st. 3rd, 2nd, very good. 3rd, 2nd, 4th, 1st was answered first of all by Bhavya. First answer that I can see which is very correct is by Bhavya. Okay, everybody got it? Everybody got it? If you have doubt in this, okay, I'll explain once again. Here, bacha, what is happening? Whenever you want to look at hydrogen bonding, right? Whenever we are looking at intermolecular hydrogen bonding, look at those molecules. First of all, understand H bonding is done by just 3 kinds of molecules, which is oxygen, nitrogen, and fluorine. Right? Understand this thing. Oxygens, nitrogens, and fluorine, only these 3 can do hydrogen bonding. Right? Now, the next criteria for hydrogen bonding should be For example, with these molecules, if already hydrogen is present, for example, with NH2, H is there, with OH, H is there, right? So whenever with these molecules, O, F and N, already if H is present, like NH2, like OH, then those will show the highest hydrogen bonding, if hydrogen is there with them. Okay? I'm telling you the trick, the funda to quickly identify. So first will be this. Second what? Second, you have now two molecules over here. One is second number, the third, next is fourth number. You have to just compare between both of them now, right? So can you see here, due to the presence of the CH3 molecule here, what is happening? This CH3 molecule is bulky, right? So this will cause hindrance in the hydrogen bonding. But this NO2 molecule over here just has few small oxygen attached. So this will show higher hydrogen bonding than this molecule. So first of all, identify the type of atoms, oxygen, nitrogen, fluorine. These will definitely show hydrogen bonding. Then, if with these atoms, already hydrogen is there, like OH and NH2, highest hydrogen bonding. Then, you have to identify if any bulky group is there, then hydrogen bondings will be less. So then it will be second, then it will be fourth. And here only OH will show hydrogen bonding. So the first will come last. Understood this thing? Understood this thing, everybody? ठीक है? Chale, everybody. Next, please stop spamming. Yes, bacha, then you can increasing orders, and obviously then you will write it like this. If increasing order is asked, it will be 1, then 4, then 2, and then 3rd. Right? So this will be how the increasing order is written. Okay? This is the decreasing order. This is how the increasing order is written. Okay? Understood? Same only, just writing different. Okay? Next, this question. Try to answer this question. The major product of the following reaction is. The major product of the following reaction is. Again, an acid is given to you, H2SO4 acid. Can everybody see that acid? H2SO4 acid, which will definitely give away the H plus ions, right? Now, where will this H plus ions attack? Where will the H plus ions attack? Yes, try to answer this question for me. Try to answer this question for me. Okay. I'm giving you 30 seconds. First answer I have received by Krishnaveni B. Krishnaveni has answered B. Okay, Krishnaveni, not correct, not correct. Nikhil has answered C. Very good, Nikhil. Shriharni C. Very good. Nikhil, very good. Neve D. No, bacha. Bineet C, Nikhil C, whoever is answered, Hemuku C, very, very good. Whoever is answered C, SBD, no, bacha. The correct answer is C. What will happen? First of all, the oxygen's lone pair will attack this H plus over here, isn't it? Now the next step would be what? After this attack, this OH2 plus will go away, forming a positive charge over here, right? So the next, what will happen? The carbocation formed is a positive charge over here. Here is the C2H5 group, and here is the double bond O group, right? Now from where will the hydrogen go away in order to cause elimination? Because we can see all our elimination products, right? Because all our elimination product, we know we have to look for the eliminated product. Now from the beta position, the hydrogen will leave. Now there are two possibilities for that. The two possibilities, what are they, bacha? From where the hydrogen will leave now? The hydrogen actually will leave from this beta position. Why? Why does this happen? Because the kind of alkene formed after that. Can everybody see? So here the double bond O, here is the alkene, and here is the C2H5 group, right? So this alkene over here is a very stable alkene, right? Because in such cases, only stable alkenes will be formed with acid like H2SO4. Stable 𝑧𝑻𝒃 product. Why is this alkene stable? Because can everybody see that this alkene can actually undergo resonance with this double bond over here, right? This alkene can undergo resonance with this double bond over here, isn't it? Isn't it? Because this is causing resonance, and the stability of this alkene will be increased, and B will not be the correct product. The correct product is C because of resonance. Due to resonance, this will undergo resonance with this bond, right? Understood, everybody? Chalo. The correct answer is C. Whoever answered C is extremely right. Next, moving on to the next question. The major product formed in the following reaction is, again, what you have given, concentrated HNO3 and H2SO4. What are these reagents for? This is a very good reagent for the creation of the electrophile NO2+. This is a electrophile. Electrophiles are positive species. HNO3 and H2SO4 create the electrophile NO2+. Now tell me, where will this NO2+ attack? This is a very interesting question. Answer me, where do you think? No, bacha, oxygen does not get the triple bond here. The actual structure looks like this. The resonating structure looks like this. This. Here is the C2H5, right? The double bond goes over here. The double bond travels over here, and this oxygen's double bond actually gets converted into a negative charge like this. Can everybody see? A negative charge like this is created. So oxygen does not get the triple bond, it actually gets a single bond. This is how the resonating structures are formed. Understood? Answer, I've already gotten C. C answer, I've gotten C answer. Okay, C answer. C, B, A. Okay, mixed answers I'm getting. So again, NO2 plus is a electrophile. So where will the positive species will attack? Where there is the maximum negative charge. So out of these species, the maximum plus I effect here OH shows the plus I as well as the plus M effect, isn't it? Here CH3 shows the plus I, just the plus I effect. Here NO2 at the meta position will actually show the minus I effect. That is it. NO2 here is at the meta position. So where will the I minus attack now? So majority of the people were saying A. No, A is OCH3NO2 plus I, plus M. Correct. A is the correct answer. A is the correct answer. Why? Because see, look at the two groups here acting. Here the NO2 group is acting and the CH3 group. So along with the CH3 group, ortho position pe attack, it will attack, and according to the NO2 group at the meta position there will be the attack, right? So the most probable attack seems to be at this position due to two group influence. Can you see? Due to two of the groups, the influence is coming out to be on this position. So the correct answer is A. Right? The correct answer is A. Shall I move to the next question? ठीक है? Understood now? You just have to understand, because there were three kinds of groups. Now how will you decide? You will decide basis on the now, because there are three groups, the two groups are saying on one position, so that position becomes the most probable position. Simple, more simple, right? ठीक है? Chalo. Next, this question. The major product of the following reaction is, okay, once again, NaBH4 in ETOH. NaBH4 in ETOH. What kind of reagent is that? That is a very good okay, not very good. That is a mild reducing agent. Not very good, okay, reducing agent, right? NaBH4 is a reducing agent in ethanol. What can be the product? Answer. First answer I have received is D. D answer, then B, Hemuku as answer. Very good Hemuku, very good Suraj, very good Maheshwaran. Very good. TN mass giving are not right. SV not right. Beneath not right. Not right. Answer is B. NaBH4 is a mild reducing agent. NaBH4 can only reduce three things, which is NaBH4. Understand one thing. NaBH4 can reduce only three things, which is your keto group, right? Can be the carbonyl group. It reduces the carbonyl group, and also the carbonyl chloride group, ROCl. That is it. It cannot reduce alkene. Alkene it cannot reduce. So the correct answer is B. It will reduce this ketone to your alcohol. That is it. It cannot reduce the alkene. NaBH4 is not strong enough to reduce alkene to alkane. So alkene will remain as such, but this will get reduced. So understand the properties of the reagents, right? So the correct answer is B. Okay? Yes, the correct answer is B. What happened, Suraj Kumar? Tired already? Okay. Next question on your screen. The major product of the following reaction is, yes, now answer this question. I will not answer this question till one of you will answer, because we have already done this kind of question. What are you asking, Beneath? I'm not understanding your question. Okay. Maheshwaran has answered A. Very good, Maheshwaran. You are extremely right. Maheshwaran, your preparation seems to be at par, right? Very good, Maheshwaran. Sumit A. Very good, Sumit. Very, very good. Very, very good, Sumit. Very good. Beneath A. Wow, very good. Arting Gallery B. No bacha. No bacha. Vemi Shetty D. No bacha. No bacha. Okay, I'll tell you one more thing. About SO3H group, right? SO3, understand, SO3 is a very big group. There is a sulfur, 3 oxygens and 1 hydrogen. This is a very big group. And big groups are very easy to leave. They are good leaving groups. If there is an order of good leaving groups, this is a very, very good leaving group. So this leaves very easily. It is very easy to leave, right? So this is a very easy leaving group. And in the axis of bromine, what has happened? We just discussed. Whenever we take bromine in axis, what happens at all the ortho and the para positions? Why? Because OH is there. OH is ortho-para directing group, right? So at the ortho and the para positions, it will be substituted by bromine, because SO3H is a very good leaving group and bromine is in excess. So SO3H will leave and the final product formed will be your A product at ortho and the para position. So correct answer is A. Hi Mishti, welcome back. Correct. Correct answer is A. Very, very good, Mishti. Very, very good. ठीक है, चलो. ठीक है, understood this thing. Let us move on to the next question once again. Okay, this is again extremely easy question. Do not get scared of this molecule. Very easy molecule. Okay, try to understand your reagent. ठीक है, when you understand that reagent, now you are not afraid of that. See, when you do not understand what a ghost is, you are scared of ghosts, you know, because you do not understand them. But as you grow up, you try to understand ghosts also, so that you can live alone and you're like, I'm not scared of you anymore, right? Because my life is more scarier than you. Okay, now try to understand this molecule. Jokes apart. Here, what do you see? Here, bromine we are taking in presence of a catalyst. AlBr3, FeBr3. What are they? They're catalysts. What is the function of catalyst? To do substitution reaction. Substitution reaction. Understand this thing. Catalysts will always perform substitution reactions. So I have already started receiving 𝑡n_mass has answered me D answer. No bacha. No bacha, D is not the answer. Praveen has answered C. Very good, Praveen. You are right. Praveen is right this time. All other people are not right. I am not receiving many answers. What happened, Sri Hari? No, D is not the answer. D is not the answer. Okay, let us look at this question. So I just told you here we are in presence of catalyst. What will happen? Substitution reactions will happen on your benzene ring. This is a very important class of, this is exactly like Friedel-Crafts reaction, right? Bromine in presence of AlBr3. What is that? Friedel-Crafts alkylation. Friedel-Crafts reaction, just like that. But it is not Friedel-Crafts alkylation, but it is a similar substitution reaction. Here the bromine will attack on the benzene ring. So where will the bromine attack? It will depend on this group. What kind of group is this? Whenever a multiple bond, as soon as you see a multiple bond in the group, do you see a multiple bond which is directly attached to the benzene ring? Hence, this is a electron withdrawing group, right? Electron withdrawing group, which means this group must be meta-directing. All the electron withdrawing groups are meta-directing groups, right? Okay? So at the meta position, your bromine will attack. So what is the correct answer now? The correct answer now, okay, there are two correct answers. See, this answer and this answer is exactly the same, isn't it? B and C are exactly the same, right? So whatever, B and C, B is also correct, C is also correct. Extremely Same answer, right? B and C. Yes, Maheshwaran, B and C, right? These are exactly same question. Again, a misprint must be there. So at the meta position, the bromine will attack. So this is the meta position with respect to this. So the correct answer is this. Understood? Understood. Shall we move on to the next question? Okay, this is the question which most of you will just be scared of and be like, I don't know what is happening. But I will tell you, this is a very easy question. What do you see? Dilute, you take a cyclopentanone in dilute NaOH. What do you think is reaction is happening? Which name reaction is this? Cyclopentanone in dilute NaOH. Which name reaction is this? Who can tell me? Okay, bacha, I will definitely make one video on rearrangement. ठीक है. Beta, which topic do you want on organic chemistry? Organic chemistry is wide. Wide. Let me know which topic you want to learn. ठीक है. Try to answer this. Which ketone? Aldol. Yes, TN Mass Gaming. Maheshwaran, aldol condensation. Aldol, Ratna Kumari, aldol. Very good. This is aldol condensation. Why? Because at the alpha carbon, there is alpha hydrogens present. There is also alpha hydrogen. Here is also alpha hydrogens, right? So alpha hydrogen is there. Hence, this is aldol condensation. Very, very good. Aldol condensation. Right. Extremely right. What should be the answer now? What should be the answer now? Yes, correct, correct. Isomerism. I've already made a video. It will be uploaded on isomerism. ठीक है, isomerism will be there. ठीक है. Aldol. Yes. Now try to answer this. What should be the product? So I just took a ketone molecule. How do you form a aldol product? In aldol product, extremely easy. I just took one ketone molecule and the another ketone molecule I will draw like this. Like this. Right? Here is the another keto molecule. Now what will I do? Now what will I do? What is the next step? What is the next step? The next step is, see, what do I do in order to make an aldol product? I make it very easy. What do I do? This is the carbon, right? This is the carbon on which the ketone. So first will remain as it is. First will remain as it is, first molecule. And at the alpha position of the first, what will I do? Then I took the second molecule. What will I do? I will change the second molecule like this. I will convert this double bond into a single bond OH, right? Now what will I do? Now I will directly attach this to this bond. That is it. That is the final aldol product. Very easy. I took one ketone and I put as it is. At its alpha position, I attach the other group and I remove the double bond O, convert it into an OH and connect it with a single bond. So this is your aldol product final. ठीक है? Understood? B answer I've already received. Very, very good. Everybody's answered B is extremely correct. Then after I heat it, what will happen? After you heat it, everybody understood how to very easily draw the aldol product. This is the correct method to draw. You will never get it wrong. Okay? Then what will happen after you heat it? Then the hydrogen will go away from here. H2O will go away from here. And the simple alkene will be formed like this. Correct? Alkene is formed now. Simple product, answer is B. Answer is B. Correct? Very good, very good. Everybody very, very good. Very, very good. Now this, again, some new kind of reagents once again. You have to focus on the reagents. You have to focus on the steps that we're taking so that you know how to approach those questions. The major product C of the following reaction sequence will be, you have been given a aldehyde over here, right? And the reducing agent is NaBH4. What did I tell you about NaBH4? That it only reduces the carbonyl group, right? NaBH4 is a mild reducing agent, right? It is a mild reducing agent. Then what will be the product A? After that, you have to react it with SOCl2. Then after that, you have to react it with anhydrous AlCl3 and your benzene ring, which means what? Friedel-Crafts reaction, B product. Then DBR C product, right? Right? Veda, what? See, everything that we're doing right now You are understanding the basics. If you solve questions, even if you solve just questions with me, even if you see how the arrows move, somebody is asking, ma'am, please tell me the basics of organic chemistry. Even if you watch these questions, right, you will learn a lot. You will see how the H plus is attacking, how the carbocation is moving, how the arrows move. Even from this, you're going to learn the very basics of chemistry, which is essential, right? Right? D, 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 D. I have already started receiving answers. Very, very good. Let's try to solve this. Okay, I have not left any place to solve this question. We'll do that. So first of all, NaBH4 will reduce your carbonyl group. So the A product after reacting with NaBH4 will be CH2 double bond CH, and here it will be CH2OH, right? So this is after reduction with NaBH4. Then you are reacting it with SOCl2. SOCl2 will do what? It will remove this OH from here, and this OH will be replaced by a Cl group, right? This will be replaced by a Cl group. So this is your molecule number A. Now this molecule number A is a what? This is now your RCl molecule, isn't it? Alkyl chloride molecule this is. Now you're trying to react it with benzene and hydroxyl3, which is a Friedel-Crafts alkylation reaction, right? So when I reacted with benzene and with AlCl3, so this Cl will go away from here as AlCl4 plus, AlCl4 minus, and what it will be left behind? A carbocation will be left over here, right? This carbocation is very, very stable. Why? Because this is a allylic carbocation, allylic position, right? After the double bond, whenever the carbocation is there, right? See, this is a double bonded carbon. Right after the double bonded carbon, carbocation is there. Very stable allylic carbon. So this allylic carbon will be attacked by the benzene ring, and the final B product formed will be the benzene ring with this CH2 double CH double bond CH2, right? So this is the product formed. Then this is your B product. This is your B product. Then your C product is the addition of DBr. How will the DBr attach? So first of all, DBr is similarly as attacking of HBr, which is your acid. So it will break down as D plus and Br minus. D is what? Isotope of hydrogen, deuterium. So here what will happen? The D will attack over here. The D will get attached over here so that the positive charge comes here, right? Now to this positive charge, the Br will, no, don't do this. Now what will happen? This positive charge can rearrange. Can everybody see? If this positive charge moves over here, then this becomes the benzylic carbocation, right? What can happen? The positive charge can move over here instead. Now the Br will attack over here. So the final answer would be the answer which is your A. A answer is the correct answer. Correct, Sumit, correct. Understood these pointers, everybody. Everybody understood these pointers. Allylic is more stable. Nitish is asking now which is more stable, allylic or tertiary. Allylic is more stable. I will also tell you the reason. Why allylic is more stable. Understand, in allylic what is happening? For example, this is CH2 double bond CH, and here is your carbocation CH2, right? Now what is happening in allylic, bacha? This can undergo resonance, right? This can undergo resonance like CH2. Here it is CH, and here it is CH2 here, and here is the positive charge, right? So here can you see a resonating structure is formed in the allylic carbocation. And always remember, whenever you're watching the stability trend, then aromatic compound will obviously be the most stable compound. After that comes the resonance structure. If in any compound the resonance structures exist, and if the resonance structures are many, then it is the most stable compound. First, the aromatic compound is the most stable, then the resonance stabilized compound, and after that will come the tertiary carbocation, the secondary carbocation, the primary carbocation. Understood? So this is the stability order followed. After that, after resonance will be your tertiary, then your secondary, then your primary, right? So this is the stability order for the carbocations. Understood, everybody? Okay? This question understood? You understood this question now? Okay? What is the order of electrophilic substitution? Beta, right now I'm not going to tell you. Beta, it depends on so many things, because I just cannot tell you the order of electrophilic substitution reactions. There is no such order, because it depends on what group is there, right? Are there ortho para directing groups? Are there meta directing groups? It depends on a lot of factors. So I will upload a shorter video on that, right? I'm creating a playlist. I've already created a playlist, and that is already live. In that playlist, I will keep on adding these things, right? And what can you do? You can do one more thing. The another thing that you can do is join me on my Telegram channel, which is Nandini JEE. That is it. This is my Telegram channel where I'll be informing you whenever on which topic the videos have been uploaded. You can go and watch them. If you are facing any difficulty, even after watching those videos, solving those examples, you have any difficulty, you can reach me out directly on this. Send me questions, we can discuss. We can plan your organic chemistry JEE. I will help you out. You can send me questions. Send me, ma'am, I don't understand this. Please, can you explain me this order, that order? So this channel would be very, very helpful for you guys. You can directly reach out to me. I've just recently created this. So you might find there are not much people there because I created it today only. Okay? Okay? Understood? You can join me on Nandini JEE. This is the Telegram channel. Okay? Chalo. Next question on your screen. The number of chiral centers present in BR. Number of chiral centers. Can I give you this as homework? Can I give you this as homework? Can you tell me in the comment section below? What you have to do? You have this product, this thing, and you're trying to react it first for Grignard reagent, and then you're hydrolyzing it, then you're forming a product A. After that product A, you're reacting that product A with again a Grignard reagent and H2O, and you're getting a product B. Then how many chiral centers with this product B have? Right? Tell me in the comment section below. So let us just stop this video here. Right? Right? Okay? 3 chiral centers. The answer is wrong. I already am telling you there are not 3 chiral centers. Okay? Ring expansion, I will definitely make that. Soni Goyal, what is your question? What is your question? Is this thing clear to everybody? Is this thing clear to everybody? Also, don't forget to join me on my Telegram channel. Once again, telling you, Nandini JEE. Find me there. Right? Chalo. Ring expansion, I'll definitely make. I will, before the second attempt, yes, but before your fourth, even before the 31st, most of the videos will be uploaded. Before 31st of this March. Right? And after that, if you are connected with me on this channel, you can directly tell me, ma'am, make a video on this, make a video on that. We need to learn more on that. Okay? So I will definitely do that with you guys. Okay? Thank you so much for attending my session. But I don't know Telugu, I just know Hindi and English. Right? I just know one word of Telugu, which is chepo, bolo, right? Rearrangement for sure, Karthik, for sure, I'll do that. Bye. Okay, you're calling me Doraemon now. Okay, thank you so much for attending. Bye, guys. Now, Shreyas sir will be here with your physics lecture. Also, please don't forget to like, share, and subscribe, right? You don't like my videos. So many people see and you don't even like it.